Okay, today we're going to be talking about horizontal asymptotes. All right, we just talked previously about vertical asymptotes and how they go up and down. Horizontal go left to right. Okay, horizontal asymptotes. How do we find them? Well, in vertical we had to do, factor, simplify, set denominator equals 0, then solve. Horizontal, we just look at our original problem. Okay, and there are 3 cases to finding the horizontal asymptote. Case number 1 would be if the degree of the numerator and denominator are the same. Okay, so if the degree of the numerator and denominator are the same, then we have a way of finding our asymptote. So looking at like an example here, x squared over x squared, the degrees there are the same. The degree refers to the highest exponent. So they're the same. So what we do is to find our horizontal asymptote is we take the coefficients of the top and the bottom, the leading coefficient of the top over the leading coefficient of the bottom. So mathematically, the leading coefficient of the numerator over the leading coefficient of the denominator. So 1 over 1, well, 1 over 1 is equal to 1. So my HA is 1. Let's say I had 3x plus 1 over 2x. That's it. 3x plus 1 over 2x. Well, our degree of the numerator is 1. The degree of our denominator is 1 because the highest exponent is 1 here. So since they are the same, I'm going to take the leading coefficient over the top over the leading coefficient of the bottom. So 3 over 2 is just 3 over 2. Okay? One more example here. Let's say I had x to the 4th, plus x squared minus 1 over x to the 4th plus or minus 3x. Okay, my degrees are the same, right? I got a 4 and a 4. They're the same. That's my highest degrees are the same. That's what I'm looking at, my highest degrees. And actually I'm going to change this to 6 and 2 right there. Okay. Since they are the same, I'm going to take my leading coefficient of the top and leading coefficient over the bottom. So my leading coefficient for the numerator is 6. My leading coefficient for the denominator is 2. So 6 over 2 gives me 3. 6 divided by 2 is 3. 6 over 2 is 3. So that is the first case for finding the horizontal asymptote, if the numerator and denominator have the same degree. Now, number 2 would be if degree on bottom is higher. If the degree on the bottom is higher, so let's just see some examples of that. So x plus 2 over x squared, x to the 3rd plus 5 over x to the 4th minus 1. All right, those are just 2 great examples right there. If the degree on the bottom is higher, so the degree on the top here is 1, the degree on the bottom here is 2, so the one on the bottom is higher. Over here you can notice that the degree on the bottom is higher. If that's the case, if the degree on the bottom is higher, you know your HA is always y equals 0. There's no changing anything. It's just y equals 0. You don't have to look for anything but the degrees, but y equals 0. That would be case 2. Case 3 is if the degree on top is higher. All right, so if the degree on the top is higher, again, some examples here. Plus 1 over x to the 3rd. X squared over x plus 2. You can notice our degree is higher on the top. 4 over 3 and 2 over 1. You see the degree over here is 2? Degree on the denominator is 1. Degree on the numerator is 4. Degree on the denominator is 3. So in this case, you just know there is no HA. So you would say no HA. No HA. Now those are the 3 cases. Again, you won't, when you see these, you're gonna think something else. You're gonna think slant asymptote, which we'll talk about later. But for case 1 is the hardest. When they're the same, you just take the leading coefficients of your numerator over your denominator, and that gives you your horizontal asymptote. For number 2, if the degree is higher, if the degree is on the bottom is higher, then you just know y equals 0. And those are your cases for horizontal asymptote.